So, good afternoon. This is my first time presenting for the PDF Association, and very pleased to be here. My name is David Stevenson. I'm a product manager at Global Graphics, and I look after a product called Mako. Mako is a C++ and C# SDK for converting, processing, and rendering PDF and other page description languages, or PDLs, and it's used by customers to develop print workflow components. So although I'll be mentioning it today, what I want to talk about is about recovering useful information, not just from PDF, but also from other PDLs. So we'll learn a little bit more about Mako later on. Why does it matter? Well, printed material is, after all, a communications medium. So naturally, the documents in a print workflow are a rich source of information. What surprised me is how important this can be for some of our customers who place a high value on being able to retrieve and recover important data and information from a printed document that's in its electronic form. And for some of our customers, it's just something as simple as knowing whether or not a job is monochrome or color, because that has implications for the cost of printing. But we also have customers who need to go deeper and to be able to extract information, perhaps to populate a content management system and make that printed material back into a useful information source. So that's why they bother. So these are some of the sort of reuse. Whoops. Careful about which screen I'm scrolling on. There are numerous use cases that require reusing document content in some manner. The simplest is just indexing content so that fast text searches can be carried out. Of course, many of you will be familiar with PDF, which has an ability to embed a search index to facilitate fast searching, but that's not true for other PDLs. A less usual requirement, and one we've helped a customer to achieve with some sample code, is to turn transactional content, in this case a pile of invoices, back into a database. This required lifting content from specific areas of the page. Easy to achieve with our technology, and a little bit later I'm going to do a short demo to show you that in action. Today, collection of evidence for legal proceedings, collectively known as e-discovery, is an exercise in identifying and collating electronic documents. E-discovery requires identification not just of text, but possibly images too. And we've demonstrated a capability of how to use our technology to leverage cloud-based AI for image recognition using Microsoft's Cognitive Services API. It was quite an interesting example, actually, and you can, we did blog about it on the Global Graphics blog. But the principle was that we took a PDF. It was a travel brochure for Seattle, appropriate given that we were using Microsoft's technology, and processed the images in the PDF, and we sent that image data to the image recognition API in Microsoft's cloud, and then got back a textual description of the image, and then we added that as alternative text to the image, so that somebody using a screen reader or other technology, enabling technology for somebody who is disabled, could tell immediately what the image actually was. It would be able to read it out to them. There are also concerns about GDPR, compliance with which has driven an interest in late-stage checking of content, before it's printed or transmitted. So this is not looking at GDPR concerns at the point that the document is authored, but rather doing it when it's being pushed into a print workflow. And we have a customer who actually looks at the PDL stream rather than the original authoring format, and to ensure that they are compliant with certain rules that they had been that they'd fallen foul of as far as GDPR was concerned. Or it may be something, you know, far more mundane than that. Already talked about the idea of knowing, you know, whether it's color or mono, simplex versus duplex, etc. So it's important to be able to capture metadata about the way the job is going to be printed as well. Or it may just be, you know, working on a database of legacy documents. So no presentation would be complete without a customer testimonial. And Rackhamy are the author of Alchemy, used by companies to perform multi-channel communications. And they use Mako to sort of normalize content. They get content from lots of different sources in multiple PDLs. It could be PostScript, could be PCL, and different flavors of PCL, PCL5, PCL, Excel. And they convert all of that using Mako into PDFX. And then that allows them to treat that content in a consistent way. They can index it, and they can search it later to find out what had been transmitted or what had been printed. They also use it for combining thousands of transactional PDFs into one for printing. And the benefit of that is that the job itself prints much faster than ripping multiple PDFs. But the way that they use our technology means that they merge font subsets, and they can eliminate repetition of common elements, such as a company logo image. Such pre-processing accelerates the ripping process as well as simplifying file handling. So now I'm going to just switch away from the presentation for a second. So let me just do that. And I'm going to do a little demo. So this is the this is a sample that I created to extract information from a bunch of PDFs. So let's have a quick look at the PDFs first of all and see what they actually look like. So that, I think, is the data. And it might help if I put Acrobat over here. So you can see there's 96 pages of this stuff. And you can see it's typical transactional stuff. So we've got some invoices. Not every page is an invoice, by the way. There are, you know, backing sheets and so on. So we need to be able to identify which page we're going to lift the data from. The way we do that is to create a template. So let's have a look at the template PDF. Oops. One. And what I did was I just created very simply some comments. So if we have a look at the comments, they probably a little bit difficult for you to read. But maybe perhaps if I roll over one of these, I'll be able to see it. And what you may be able to notice is that I've added some JSON information. So the idea is that I've got JSON that actually identifies a field and what its type is. So that one, for example, says name, amount due, type, number. And the I've created just some rectangular comments as to define the area that I want to lift the information from. And I've also capturing the QR code here. Well, it's not a QR code, it's a mailing code, and the address as well. So that is the so that's template created very simply. I just did that in Acrobat. I didn't need to use a dedicated tool for it. And then what we do now is we run something called Spec Maker. So what that does, if I just run it first of all, it takes an input PDF and it identifies where those extraction areas are and builds up a list of the fields that it is going to capture. And then it outputs a JSON file that we can use with the actual extraction program. So let's run that and see what happens. So I need to just supply the template PDF, and I don't think I need anything else really. I think that will do the job. And now if we have a look at the files, you'll see I've now got a template JSON file. So we can take a look at that, and now this should fire up in Visual Studio Code. So again, I'll have to move that over here. And what I've ended up with is those field names that I'd already defined inside the comments, but now I've got some coordinates for the areas where we want to retrieve the data. So with the template created, let's just remind ourselves what we've got. So now we've got the data extractor program, and if I run that, it tells me that my input PDF, so that's going to be the one, the first file that we looked at with the 96 pages. I've got to specify an output file and also the specification JSON file that has got all of the coordinates in it. So let's run that now. And I need that, and I need spec equals, and that should do the job. And with any luck, oh, there he goes. So it's found some data, and take another look now. We've now got a CSV file, and if we take a look at that, and this of course will fire up in Excel, which again I'll probably have to move over to my display window. And there's all of the data, so there's the dates. And one of the things that that kind of surprised me is that the font that is used for the QR code it's actually supplied with a text string that describes the on/off for the dots of the code. And I actually captured that text because obviously it's in the it's just in the font. So so you could actually sort of even work out exactly what the code would be. Anyway, so that's a very simple example, but an example of the type of thing that that we find customers want to do. They want to be able to effectively reverse engineer content that exists only as a printed document. And there are lots of other ways of doing this, but some of the when a customer wants to do something, let's see if we can get back to there. Wants to do something which is customized and built into their workflow, then they can use our technology to develop that. So moving on. So there may be those who are on the call who disagree with the first bullet of this slide, that PostScript can be represented in the PDF. But generally speaking, that's true. The PDF is obviously a superset of the PostScript display model. But for other page description languages, that's not so easy. But the way that our technology works is we try and take the same approach. What we do is we have Mako's architecture extends this idea to other PDLs. Using an approach that populates our own document object model, or DOM, with a native parser for the other formats shown here. So what that means is that we can do conversion in any direction from any format to any format. And using a common DOM means that we allow for a very rich conversion from one format to another, so nothing gets lost. The font information, the text, and so on is carried over into the target when you're converting. So here we've got going into slightly more detail here. So what we do is we use and we parse those different formats and create a page in our own object model, and then the DOM, of course, represents the document and page content in a format agnostic way. So we can operate on that content. It doesn't matter whether it's come from a PDF or for a PCL file. We can operate on it in exactly the same way. And so, I could just as easily have created that example using, a PCL as an input format. The DOM is also capable of storing metadata, so it goes beyond what PDF would typically allow for, and we will process PJL in order to store that metadata, and we store it as print tickets within our DOM. So this means that we can retain settings to do with duplex printing or tray or media selection in the document object model. The other thing is we do as well is we will do our absolute best to deal with fonts. It goes without saying, really, that accurate text acquisition relies on identifying the correct font encoding so that the glyph runs can be turned back into usable text. Our DOM stores fonts as OpenType or Type 3, identifying symbol sets and bifonts and so on. And we also fix fonts that may not be formed correctly during this process. And anybody who has dealt with PDF will know that fonts can be a constant source of frustration because they are not always necessarily encoded correctly. We've even applied OCR. It's not actually part of the standard product, but we've demonstrated a capability of using it to actually use OCR to identify glyphs. So if in the absence of nothing else, if all you have is a bitmap, then you could use OCR to identify the glyph and then encode it correctly within the PDF. And we've spent a lot of time sort of perfecting this technology and making sure that it works in all of those different conversion directions. Oops. The other thing that that PostScript and PDF offer, of course, is much superior color capability than your typical PDL. So for PostScript and PDF, our DOM supports ICC-based color spaces and profiles processed by a built-in CMM for accurate color conversion and rendering. And I mention this only in the context of what we're talking about here, because we have customers who are very keen to kind of upscale content that perhaps have been developed originally just to be printed to PCL devices, and they need to be able to turn it into something that where they can control the color, so that they can get a better result on a press, and they need to be able to apply color management to that. Our technology certainly allows them to do that. The second bullet here about ROPs is kind of interesting. They enable colors to interact. They're part of the PCL standard, and they're also present in other formats such as IJPDS, and they are a pain as far as conversion is concerned, because you have to process them in order to know what the colors are going to look like. And one of the things that we've done for our customers is to switch ROP processing off, so that they can get the benefit of fast conversion and fast extraction of information when they don't really care about the appearance of the file. Once it's converted, they're only really interested in getting the information out. So here's the sales bit. You may say that I've been selling all along, but the technology I've been describing is Mako. It's a software development kit from Global Graphics, as I've said, that our customers use to develop print workflow components, and it's available for multiple platforms: Windows, Mac OS, Linux, etc. And on our website, if you go to our website, you'll see that we describe it as a Swiss Army knife. It has lots of blades, each one matching a job that you need to get done. And so you choose the particular tool that suits your needs, and write some code either in C++ or C#, using a rich set of APIs that give you control over color, fonts, text, images, vector content, all of that stuff. But although it's an SDK that clearly can deal with other PDLs, it has a particular focus around PDF. So that brings me to the sort of presentation part of the of my session today, and I'm hoping now that stuff will.
Yep. What would you need?
Will come in. So I'm kind of at the end of the presentation. I can talk for a little bit longer if you would like, but
that's great. Are there any questions?
Have any questions?
I don't see any at the moment.
No.
David's slides are posted in the control panel. They're available for your download if you're interested. And if you have a question, go ahead and please post it into the question pod. So, David, one question we've received. Could you share some more about your image extraction to alt text project?
Okay. Let me see if I can find a link to the blog.
Well, okay.
So I'll see if I can find the the actual. No, well, I'll see if I can find that, and I'll see if I can post it. So yeah, I'll tell you a little bit more about it then. So I described the exercise that we did. So we the Mako code loads the PDF into our DOM, and you're then able to walk the content in a number of different ways. But you can identify areas of the page which contain an image. So the hierarchy is actually an image brush that contains an image, and then you can get the image data. So we take the image data and then upload that to an Azure-based service. So it's one of Microsoft's cognitive APIs, and it does image recognition. So, for example, in the Seattle document, it's a shame I haven't got I don't think I've got the actual file on my system at the moment. There was a picture of somebody skiing, and the AI correctly identified person skiing, and so we just add that as the and we just tag the image using the alternate text tag. And the idea then is that a screen reader or assistive technology can pick that up. So somebody who's visually impaired could be reading the PDF, having the content read to them by a screen reader, and then when they encounter an image, the screen reader can read the alternate text of the that was put there by the by our program that had identified the image from the AI. So I'll see if I can find the URL to the blog. It's actually got full details of exactly how we did it. It's even got some code snippets in there as well. It's it was just an exercise because we like the idea of using the cognitive APIs. They're available from Microsoft, and if you're providing you don't hit their service too many times, it doesn't cost you anything. So it's pretty cool.